Good morning, everyone. Again, hope you're all staying safe. In today's lecture, we are going to continue talking about Chapter 7 and the cost structures of firms. Specifically, in today's lecture, we will be talking about the economic analysis of costs. So we will be looking deeper into these cost curves facing our firms, why they are U-shaped, for example, what are the determinants that determine the costs facing any firm, and so on and so forth. So what do you think could be the factors that determine the total cost facing any producer? Okay, so for any producer to produce any amount of the good he wants to produce, he needs, of course, different factors of production like land, labor, capital. Okay, so the cost facing this producer will be determined by how many units of each factor is required and the cost per factor, okay, or the price of each factor of production in the market. These two factors will determine the total cost facing the producer who wants to produce any amount of output. Okay, so let's summarize these two things in the two main factors determining the cost curves. The first one is factor prices. Prices of inputs like labor and land are important ingredients of costs. Of course, higher rents mean higher cost for the producer. Higher wages mean higher cost for the producer. Okay, so this is what we mean by factor prices. The second main factor that determines the cost facing a producer is the production function. If you remember when we talked in chapter 6 about the production function, we said that a production function gives us the maximum level of output that can be produced using certain amounts of each input or each factor of production. Okay, and we saw how technological advances and technological improvements, okay, could result in shifts in the production function or in the total product curve facing our producer, which will allow him to produce the same level of output with fewer inputs, okay, which means lower costs facing our producer, or which will allow him to use the same level of inputs to produce more output. Again, this will result in lower costs for our producer. So when I said that the two main factors that affect the costs facing our producer are summarized in how many units of each factor of production is required, this is given to us by the production function. So this information is given to us by the production function. So again, there are two main factors that affect the total cost facing any producer. The first one is how many units of each factor of production is required, and this information is coming from the production function facing any firm, because the production function tells us how many units are required, okay, to produce a certain level of output. And the second factor that determines the cost facing any producer is the price of each factor of production in the market, okay, which is what we call the factor prices, okay. In the next slide, we're going to take a look at a table that will help us better understand how these two factors together determine the total cost facing any producer. So this table shows us how, by knowing the input prices and the production function facing any producer, one can calculate the cost curve or the total cost facing this producer. So if we look at this table, in column 1 we have the output that will be produced, which is Q. Here we are talking about tons of wheat that will be produced. Okay, starting from 0, no production yet, until 6, for example. And then the second column we have land inputs. How many units, how many acres of land will be required to produce wheat for our producer? In this case, this is the fixed factor of production that will be required. Here, according to this example, 10 acres of land are required to produce wheat for our firm. The third column represents the labor inputs, which is the variable factor of production, as we will see later, okay? It starts from 0 until 45. So column 2 and column 3, okay, will give us the production function in order to produce each level of output. So column 1, 2, and 3 together will give us the production function facing our producer, because they will tell us if you want to produce this level of Q, this level of output, how many units of each factor of production will be required. And this is what we mean by the production function. Okay. Column 4 and 5 give us the factor prices. So in column 4, we have the land rent per acre, okay, which is $5.5 per acre. In column 5, we have the labor wage, which is $5 per worker. Okay, so the total cost facing our firm will be calculated as follows. We are going to multiply each factor by its price, okay, and this will give us the total cost. So in order to produce zero output, you will definitely start paying for the land that you have rented, the 10 acres of land, which is 10 acres of land times 5.5 per acre, which is 55. This is the fixed cost facing our producer, even if he hasn't produced yet. Plus, since he hasn't produced yet, he will not start hiring labor. So it will be 0 labor times 5 wage, which is 0. So the total cost in this case will be 55. So to produce 0 output, before starting producing anything at all, the total cost facing our producer will be 55, which is the fixed cost of the land rent. Okay? To start producing 1 ton of wheat, our producer will stay paying for the rent, the 10 acres of land, which is 10 times 5.5, 55, plus he will start hiring 6 workers in order to produce 1 ton of wheat. And each worker will be getting $5, so it will be 6 times 5, which is 30. So the total cost facing our producer, if he wants to produce 1 ton of wheat, will be 55 plus 30, which is 85. Okay? So as you can see, to calculate the total cost, we needed 2 pieces of information. The first one is the production function, which tells us how many units of each factor of production is required to produce a certain level of output. And this information we get from column 1, 2, and 3. And the second piece of information that we need to calculate the total cost is the factor prices, okay? The price per factor of production required to produce that level of output. So together, these 2 pieces of information will help us calculate the total cost facing our firm. And as you can see, the total cost, which is column 6, increases as output increases. But at which rate? This is what we will be talking about again when we talk about the marginal cost. So now we know how we can calculate the total cost facing any producer. Now it's time to understand, why do we have U-shaped cost curves? If you remember from the previous lecture, the marginal cost curve and the average cost curve were both U-shaped. This means that the cost was falling in an initial phase, reaches a minimum point, and then started to rise. So why do we have this phenomena of having U-shaped cost curves? This has something to do with the short run and the long run that we talked about previously. And this is what we will explain in the next slide. So let's recall what we mean by the short run and the long run. So briefly, the short run was that period of time where the firm was facing both fixed factors of production and variable factors of production. So in the short run, each firm will be facing some fixed factors of production, such as the land size, the plant size, and the equipment that it already imported from abroad, for example. All these represent fixed factors that cannot be fully adjusted in the short run. However, at the same time, in the short run, the firm is facing some variable costs, okay, which are the costs of those factors of production that could be adjusted, like labor, for example. Because labor is considered a variable factor of production, the firm can hire more and more labor as much as it needs, okay, so it's a variable factor of production. That's why it represents a variable cost for the firm. So in the short run, a firm will be facing both fixed factors of production, fixed costs, and variable costs of production. In the long run, however, all inputs to the production process can be adjusted, including land, labor, raw materials, and capital. Hence, all costs to the production process in the long run will be variable, and there will be no fixed costs of production. So again, in the short run, the firm will be facing two types of costs, fixed costs and variable costs. In the long run, the firm will be facing only variable costs. There will be no fixed cost because there will be no fixed factors of production. All factors of production will be variable. All factors of production can be adjusted in the amounts used of each of them. So what is the relationship between the short run and the long run and our cost curves? What's the relationship between the short run and the cost and the long run, and how the cost curves look like and why they are U-shaped? So in the short run, when factors such as capital and land are fixed in supply, those variable factors like labor will tend to show an initial phase of increasing marginal product followed by diminishing marginal product. What will be the implication of this on the cost curves? The corresponding cost curves will show then an initial phase of declining marginal costs followed by an increasing marginal cost curve when diminishing returns start to kick in. That's why it's a relationship between the productivity laws, okay, how the productivity of each factor of production, how the marginal product of variable factors of production, okay, will depend on the short run versus the long run, and how this will affect the marginal cost facing our firms. The next graph will clarify this point even further. So I'm going to use these two graphs in order to clarify the relationship between the productivity laws, okay, and the shape of the cost curves. So as you can see, the graph on the top, okay, this is a graph where we have labor, the quantity of labor hired on the x-axis, and we have on the y-axis the marginal product of labor, okay. The graph at the bottom, we are having output, number of units of output produced on the x-axis, and we have the marginal cost on the y-axis. So how are we going to use these two graphs in order to clarify the relationship between the productivity laws and the shape of the cost curves? So let's consider the short run, in which capital is fixed but labor is variable. Okay, so in the short run, we agreed that there will be some fixed factors of production and some variable factors of production. So in our example, okay, let's assume that capital is the fixed factor and labor is the variable factor. in such a situation, the following will occur, or the following will happen. There will be an initial phase of increasing marginal product of labor. Okay, so in this scenario, there will be an initial phase of increasing marginal product of labor, which is clear from the top graph. There will be an initial phase of increasing marginal product of labor until 15 units of labor are utilized or hired. However, this phase of increasing marginal product of labor will not last for long. It will be followed by a phase of diminishing returns to our variable factor, which is labor. What do we mean by diminishing returns, phase of diminishing returns? This means that it is a phase where the marginal product of labor will be declining, will be decreasing. And this phase will start to kick in very soon. And this is very clear from, again, the top graph, where after 15 units of labor are being hired, we will face a phase of diminishing marginal product of labor. The marginal product curve will start decreasing. But why is this happening? This is happening because each additional unit of labor, because we are in the short run, where capital is fixed, this means that each additional unit of labor that the producer will be hiring will have less and less capital to work with, because our capital stock is fixed. So each additional unit of labor hired will be having less and less capital to work with. And this will result in a decrease in the marginal product of this labor. Okay, that's why our marginal product curve will look as it appears on the top graph. There will be a phase of an increasing marginal product, followed very soon by a phase of diminishing returns to labor or decreasing marginal product of labor. So how is this going to affect the shape of our cost curves at the bottom graph? As a result of this shape of the marginal product curve, we will find that the marginal cost of output will be initially falling, as is clear from the bottom graph. The marginal cost curve will be initially falling, but will quickly be rising afterwards. Why is this happening? Why is this going to happen? Because the extra output produced by each extra labor will be going down. And this is what will be causing the marginal cost to be rising. So in other words, the fact that the producer is facing diminishing returns to the variable factor of production will imply an increasing marginal cost curve facing the producer. So as you can see again, the marginal cost curve will be falling in the region when the marginal product of the variable factor, the marginal product of labor, was rising. Compare the top graph with the bottom graph. So if you look at the bottom graph, the gray curve of the marginal cost, you will find that in the region A to B, AB, okay, the marginal cost will be falling. And this will be the region where the marginal product was rising. It is AB in the top graph on the pink solid curve. And then the marginal cost will start rising when the marginal product curve will enter the phase of diminishing returns. So this is the relationship between the productivity laws that depend on the fact that we are in the short run and that our variable factor is increasing at the same time when the fixed factor is fixed. So it is this short run that is causing these productivity laws and having a phase of increasing marginal product followed by a phase of decreasing marginal product, okay? And this is why our cost curves will have a U-shaped. So this is the relationship between the productivity laws, okay, and the shape of the cost curves. So now we know how the total cost facing any firm can be calculated, and why the shape of the cost curves is U-shaped. Okay. Now it's time to know how the firm chooses its inputs or its factors of production. Every firm must decide how to produce its output, i.e., whether to use a labor-intensive technology or a capital-intensive technology. This is a decision that the firm has to make, whether to use a labor-intensive technology or a capital-intensive technology. In other words, whether to use a production function that relies more on labor or more on capital. Because every firm, before it produces, it faces a number of production functions that it has to choose one of them to use in its production. So there are some production functions that use more labor, which we call labor-intensive techniques, and there are other production functions that use more capital in the production process, and these are called capital-intensive techniques. So what are the factors that help the firm decide on which production function to utilize? For example, should LG plant in Egypt produce its LEDs and LCDs using more labor, i.e. labor-intensive techniques or labor-intensive production functions, or more capital, i.e. capital-intensive techniques? The same question applies for the LG plant in Germany. Should it be producing its LEDs and LCDs using more labor or more capital? So this is the question that each producer has to decide on before starting the production process. And definitely there is a certain assumption that we have to make that could help us answer this question. And this is what we're going to talk about in the next slide. So the assumption that we're going to make regarding firms and producers, okay, and which will help us answer the previous question is the following. Firms aim at minimizing their cost of production. Any producer will be aiming at minimizing his cost of production. This is the assumption that we'll be making regarding our producer. This cost minimization assumption makes sense not only for perfectly competitive firms, but it is also a sensible assumption for monopolists and even for non-profit organizations like hospitals, like colleges, okay, those organizations that do not aim for making profits. But the same assumption applies for them, that while managing their production of a good or of a service, they aim at minimizing their cost of production. This assumption states that the firm should strive to produce its output at the lowest possible cost. And this will result in having the maximum amount of revenue left over. So if you remember, what is the total profit of any firm? It is equal to the total revenues minus the total cost. So by assuming that every firm, whether firm that aims at maximizing profits or a non-for-profit organization, okay, by assuming that it will aim at minimizing its costs, this means that it will be hoping to maximize its revenues, okay, the amount of revenue left over. And this maximized revenue will either go for profits or for other objectives if it is a not-for-profit organization, like for charitable work, for any other objective. So this is a sensible assumption that we can make to any producer of any commodity or of any service, whether this producer aims at maximizing profits or even for firms that are by nature not-for-profit organizations like colleges and hospitals. So let's take an example to show how a firm will decide between different input combinations or different production functions. Let's suppose that the firm's engineers have calculated that the desired level of output of 9 units, okay, which is desired by the firm, could be produced with 2 possible options or 2 possible production functions. And these 2 production functions are actually a function of 2 factors of production, which are energy and labor. So the production function is Q equal F function of E, energy, and L, labor. Okay, so the 2 options, the 2 production functions that will be offered by the firm's engineers, okay, they are both a function of energy and labor. And according to the market prices of energy and labor, energy costs $2 per unit and labor costs $5 per hour. Option A, production function A, in this production function, the input mix will be the following. 10 units of energy will be required and 2 units of labor will be required. Option B, however, will be utilizing 4 units of energy and 5 units of labor. So which option do you think our firm will be choosing? In order to decide on this, the firm has to calculate the total cost associated with each option, with each production function. Because according to our assumption, every firm will want to minimize its cost of production. That's why it has to calculate the cost associated with option A and the cost associated with option B, and it has to choose the one that minimizes the cost, the one with the lowest cost. So the total cost associated with option A will be the following. 2 units, 2, which is the price of energy, times 10, which is the number of units of energy required in option A, plus $5, which is the cost per hour per labor, times 2 units of labor required, which will give me $30. The total cost for option B, however, is $2 times 4 plus $5 times 5, which is 33. Therefore, option A would be definitely the preferred least cost combination of inputs that will be chosen by our firm. In the previous example, our firm was facing just 2 options, A and B, just 2 production functions. And it had to calculate the total cost of each one of these 2 production functions and choose the one with the least cost. However, in reality, there are usually many possible input combinations, not just 2. But luckily, we do not have to calculate the cost of every different combination of inputs in order to find the one which costs the least. Why? Is there a simple way to find the least cost combination? Yes, there is, and this is what we will be explaining in the next slide. How can our firm calculate the least cost production function without having to calculate the total cost of every possible production function it is facing and choosing the one with the lowest total cost? There is a very easy method by which the firm can reach its least cost combination of inputs that it will be choosing for its production process without having to do this hassle of calculating the total cost associated with each production function it is facing. So these are the steps. Start by calculating the marginal product of each input to the production process. So the first step we're going to do is to calculate the marginal product of each input. Then the firm will be dividing this marginal product of each input by its factor price, by this input's price. This will give the firm the marginal product per dollar of input. So the cost minimizing combination of inputs will come when the marginal product per dollar of input is equal for all inputs. In other words, the marginal contribution to output of each dollar spent on labor, land, oil, and so on must be just the same. Let's look at the next slide, and I'm sure this will be ringing some bells for you. Previous steps that we followed in the previous slide will result in what we call the least cost rule. So what is the least cost rule? For a firm to produce a given level of output while minimizing costs, i.e., for the firm to choose the least cost production function, this firm should employ inputs until it has equalized the marginal product per dollar spent on each input. This implies that the marginal product of labor divided by the price of labor should be equal to the marginal product of capital divided by the price of capital, should be equal to the marginal product of land divided by the price of land, and so on for all factors of production used in the production process. Does this rule ring any bells for you? MPL over PL equal MPK over PK equal so on? Yes, definitely this rule rings some bells for you, or at least I hope so. This rule is actually analogous to what consumers do when trying to maximize utility. If you remember our consumer theory, in that theory we saw that a consumer who wanted to maximize utility had to purchase goods until the marginal utility per dollar spent on each good, which is marginal utility of good X, for example, divided by the price of good X, was equalized for all goods. So this was the rule for utility maximization in the consumer theory, and this is the rule for cost minimization in the producer theory. So our producer, who aims at minimizing costs, will employ inputs to the production process, will employ certain amounts of each input until this employer or this producer has equalized the marginal product per dollar spent on each input, until MPL over PL equal MPK over PK, and so on. So this is a very important rule in the theory of the firm, which is the least cost rule. This is the rule that guarantees that our producer is producing while utilizing the least cost production function. Okay, and this is a substitute to having to calculate the total cost of each possible production function and choosing the one that will be having the lowest cost. Are there any implications to this least cost rule? Yes, definitely there are, exactly like the implications that we talked about in the consumer theory. The first implication, and the most important implication, is the substitution rule. What is this substitution rule? If the price of one factor falls while all other factors of production, their prices remain the same. This means that firms will profit by substituting the now cheaper factor for the other factors until the marginal product per dollar spent is equal for all inputs. Let's take an example in order to understand this. A fall in the price of labor, for example, will raise the ratio MPL over PL. Why? Because the ratio MPL over PL, which is one of the ratios in our least cost rule, okay, when the price of labor falls, okay, the denominator will fall, which will raise this ratio, MPL over PL. It will increase this ratio above the other ratios in the least cost rule. What will happen in this case? What will happen is that the producer, in this case, seeing a decrease in the price of labor, in the wage of labor, okay, will raise the employment of labor, will hire more labor. And this will definitely result in a reduction in the MPL by the law of diminishing returns. If you remember the law of diminishing returns, okay, hiring more labor will result in a decrease in the marginal product of labor and will then result in lowering the ratio again, because the marginal product of labor will decrease and the overall ratio will decline again. And this will bring the marginal product per dollar for labor back into equality with that ratio for other factors. And the equality is again restored, but when? After the producer has substituted the cheaper labor for other factors of production. Now he will be employing more labor, and after this, the equality will be restored. So this is the main implication of our least cost rule. It is an implication related to the substitution between the different factors of production and how a change in the price of one factor of production will result to more demand for this factor of production, which will restore the equality again.